In this video, we will learn about chemical properties. The first one is neutralization reaction. Bases neutralize acids to form salt and water. So base on reacting with acid produces salt along with the water. Here is the example, which is NaOH on reacting with acid produces salt, which is sodium chloride, and the water. Similarly, calcium hydroxide on reacting with hydrochloric acid produces calcium chloride and water. Then copper hydroxide on reacting with H2SO4 sulfuric acid produces salt, which is copper sulfate and water. Then precipitation of heavy metal ions as their hydroxide. So when metal salts react with bases or alkalis, means water soluble bases, they form salts and insoluble hydroxide are precipitated. So example we have, this is a metal salt which is copper sulfate. It reacts with base or an alkali which is sodium hydroxide. It produces a salt which is sodium sulfate, and an insoluble hydroxide which is copper hydroxide, light blue in color. It will get precipitate. Similarly, we have iron chloride which on reacting with sodium hydroxide produces salt as sodium chloride, and the brownish iron hydroxide will be precipitated as insoluble hydroxide. Then zinc sulfate on reacting with sodium hydroxide produces sodium sulfate and zinc hydroxide, which is white. Then aluminum sulfate on reacting with sodium hydroxide produces sodium sulfate along with the precipitation of aluminum hydroxide, which is dirty white in color. So the hydroxides of zinc, aluminum, lead, etc., these are being amphoteric in nature, dissolve in excess of sodium hydroxide. For example, zinc hydroxide on reacting with sodium hydroxide produces Na2ZnO2, which is sodium zincate along with the water. So amphoteric means they react with acids as well as with the bases. Here you are able to see that zinc hydroxide is basically, it has to be basic in nature, but no, it is reacting with hydroxide, which means that it is behaving as an acid. Zinc hydroxide has to be basic in nature, but it is behaving like an acid here. So that's why they are said to be amphoteric in nature. Then we have decomposition of ammonium salts. Strong alkalis like NaOH decompose ammonium salts to evolve ammonia. A less volatile base means which cannot be converted easily into water vapors, that is NaOH displaces a more volatile base, that is NH4OH, to form its salt. Here is the example. We have a more, basically a salt NH ammonium sulfate, which on reacting with sodium hydroxide, which is a less volatile base, produces sodium sulfate along with the water and ammonia, which is volatile in nature. So ammonia is a more volatile base than the sodium hydroxide. Similarly, ammonium chloride on reacting with NaOH produces NaCl and the ammonia. Then reaction of bases, alkalis with the water, with metals. Metals like zinc, aluminum, tin, lead, they react with strong alkalis like NaOH, KOH in order to evolve hydrogen gas. So zinc on reacting with sodium hydroxide produces sodium zincate along with the evolution of hydrogen. Then also tin react with sodium hydroxide to produce sodium stannate along with the evolution of hydrogen gas. Similar reaction happens with the aluminum, which on reacting with sodium hydroxide produces sodium aluminate along with the evolution of hydrogen gas. Then reaction with non-metal oxides. Bases alkalis, they react with non-metal oxides which are acidic in nature to form salt and water. Base on reacting with non-metal oxide produces salt and water. So sodium hydroxide on reacting with non-metal oxide produces sodium carbonate along with the water. Then calcium hydroxide on reacting with carbon dioxide produces calcium carbonate and water. Then similarly, calcium hydroxide on reacting with sulfur dioxide produces calcium sulfite along with the evolution of water. I hope it is clear to you. Thank you.